I'm not going to be extremely granular. I am respectful of the fact that we've all been here in an intellectual, relatively high-intensity environment with a bombardment of thoughts. Eric, I'm still quite emotional from what you said. It's very intense, and it's true. The thing that we are doing here is something that is not just a job for us. It's actually the thing that we want to do. It's the thing that we want to do with our lives. It's the thing that we feel needs to be done. And it's also the reason why we do it. If we feel this is not the right thing to do, if it doesn't want to be built, we wouldn't be doing it. We would be doing something else. But this is actually the thing that we feel has to happen somehow. And it has to happen probably here, because this is the place where machines are built that think and that have agency. And this is the place that needs this contribution. And this AI perspective on consciousness that we have is a perspective that is not obvious to everyone everywhere in the world, and not as obvious as it is to many people in San Francisco.
AI systems with theory of mind and self-reflection are very, very far in the future.
AI that thinks like us is probably impossible.
Yeah.
There's no way they can perceive.
There's no way
It's just they can perceive.
Yeah,
Right?
it's all just based on computation and probability.
Computation is not enough.
You cannot learn from data alone. You need embodiment and interaction with the real world.
I think that only biological substrates can perceive, have intentions, produce thought.
Absolutely, and that needs to be stated firmly and clearly.
It's hard to believe my experience could be a dream of AI.
No, right? This is a weird thing. I am part of this generation where computers could always play better chess than us, than me. Right? If I go back to when I was a child and started playing chess, I think I'm better now at playing chess, even though I'm not very good as computers were back then. But they basically developed so much ability in this particular domain that they outcompeted most of us in my generation all the time. And in the same way, there are now many disciplines, it's quite jaggy, where the AIs are outcompeting human beings. And one of the areas where they're actually better than human beings for quite some time now is AI criticism. Right? This was obviously generated by Google's new vision model, the video model VO3. And what you can see are actors that never existed, that expressed emotions that nobody had. So this current approach to simulate human ability is working in many isolated domains. And it also points to the possibility that current systems are already in the ballpark of what it needs to reproduce our performance, purely on the level of being able to solve certain problems, to produce certain behaviors, to console certain outputs. But the foundation models that do this are very unlike brains, and deep neural networks are very unlike biological neurons. Instead, these are systems that have been trained to reproduce the human performance based on data that contains human output. And so there is this question, is this intelligence that we see in the machines a deep fake? And in a way it is. You can see this when you start training the models. It's like an onion that you train, built from the outside in. If you train your language model on text, you get something that is emulating some of the statistics of text, and what you get looks almost like human language. And then train it a bit more, and you have the next layer of the onion underneath. It finds grammatical structure. And you go a little bit deeper, and the thing looks like a coherent text, and it loses coherence after a paragraph or so. And then you go deeper, and then it holds coherence for almost a couple of pages. And you train it on the entire internet, and it's almost fully coherent. And so there is this weird thing where you have this onion that goes from the outside in, and you train it more and more, and gets closer and closer. But the middle of the onion is somehow still empty. There is no proof that this is not good enough. Maybe this hole that remains in the middle, if you emulate the performance, is smaller than the noise in our own brain, because our own mind is only approximating me to some degree. Right? If I understand myself as some kind of an aesthetic of what it would be like if I existed, then my mind is simulating that being to a certain degree of approximation, but I'm not always fully awake. I'm never fully awake, and sometimes I'm exhausted and noisy. And so the question is, are these holes that exist within myself and my own aesthetics as a being that is approximating a conscious, sentient, goal-directed observer that ties itself into a larger set of meanings that are given by the ways in which I can exist and coexist in this universe? Is this something that I'm not better at than these machines that are emulating me? But the way in which I'm growing is from the inside out. I start with the spark that is building itself machinery in a human brain that eventually learns language and gets better at it. And so I start out with this core of coherence. That is a different thing there. And so if a difference between the current AI algorithms and mine's. AI algorithms have an outside-in design. They're stabilized because they run on a fully deterministic substrate that the programmer can fully control. And it's trained on static data that is decoupled using prediction paradigms, using machine learning training algorithms. And the way in which we organisms work is we are designing ourselves from the inside out. We need to have self-organization. We need to be coupled with our environment. We have this dynamic coupling in which we are in resonance with the world around us. And we try to achieve coherence in our models of reality around us. And we develop continuously instead of just being trained once. And so the core question that I want to ask is, what is the shape of this strange loop, this seed function that grows our mind? And can we perhaps rediscover it using artificial substrates? So what should a theory of consciousness deliver? In my view, first of all, it should say, what is exactly the thing that we are looking for? It doesn't help if I redefine consciousness as something that is completely simplistic, but can be had by a Roomba or a self-driving car, which I don't think are conscious. We need to actually account for the phenomenon that we want to describe and agree on it in a meaningful sense. We need to explain these observables in a causal model. So it's not sufficient to say there is this kind of mechanism that correlates with it somehow. I want to know why it's actually happening this way. And so we need to specify necessary and sufficient conditions. Under these conditions, is this experience going to unfold? And this theory should also be grounded in evidence, so we can actually see this relates to the world in which we are in and in the way in which we function. And it allows us to test theories in a solid way. And ideally, it should also explain what consciousness is for, what its purpose is, and how it comes into being. So asking this question, what is the phenomenon that we want to explain? Introspectively, we find that we experience sensory features as an immediately given reality. Philosophers usually call this qualia. And we have a second-order perception. It's not just a higher-order thought, it's a perception. We perceive ourselves in the act of perceiving. We notice that we are noticing. We are observing that we are observing. It's a second-order perception. And consciousness is always happening now. It creates this bubble of nowness that we subjectively inhabit, a sense of being present and something else being present. And usually we perceive consciousness inhabiting the surface between self and world. And it's not the surface of my body, but it's the surface of a model what I am, inside of a model what the world is. Both of them exist in my mind. And consciousness is usually projected in there, and we experience this as a first-person perspective. But I don't think that you need to have a first-person perspective to be conscious. You can be conscious in dreams in which you look from nowhere, or you can meditate and be in states in which there is no self present, and you can experience that awareness is happening, but there is no I. Another way of looking at consciousness is not to characterize it via phenomenology, but by mechanisms. And this is the way in which science traditionally goes about it. So if we look at the behavior of the biological neurons and the structure within the cells, and we try to identify mechanisms and measure them using a set of technologies like EEG and fMRI and brain-computer interfaces, and analyzing the spectrum using experiments, using anesthetics and a lot of other techniques. And in this way, we try to elucidate the functional correlates, the physical mechanisms behind it. But somehow we are stuck with what David Chalmers calls the hard problem. And I suspect that this hard problem is something that is not universal in all cultures. It's something that our culture seems to be much more concerned about than, for instance, Japanese culture or Chinese culture or the ancients. It's something that has to do with the problem of reducing phenomenology to mechanisms, because this mechanist worldview that we have is something that has not been around forever. It's something that evolved in modernity. It evolved in the 20th century. And so it's very difficult to map phenomenology to mechanisms. And this difficulty was not only discovered by behaviorists in the 20th century or by John Searle, but it has been described as early as by Leibniz. And Gottfried Wilhelm Leibniz is a philosopher who suggested, imagine that your mind would be like a mill. It's made out of all these parts that are pushing and pulling at each other. And now you enlarge this thing to the point where you can walk into it. And you look at all these parts and you see all these wheels grinding at each other. But where is there a perception? Where is there a feeling? Right? This cannot possibly explain it. It's a category mistake to try to explain it in this way. And there is a third way to look at this, and this is the functionalist perspective. And from the perspective of functionality, we can ask ourselves, what does consciousness do? What kind of behavior is it? It's an operator on mental states. How do my mental states change when consciousness comes along? Right, so how do my mental change between being in deep sleep and waking up? How do my mental state change when I lose consciousness? How do my mental state change when I have a mental episode in which I self-reflect? And so on. So all these things that consciousness is involved in, alertness, coherence, selective response to environmental stimuli, decision-making, attentional learning, all these things require consciousness and conscious attention. And what we observe is that consciousness seems to have a role that is somewhat similar to the conductor of an orchestra. All the instruments can produce behavior that is autonomous, but the role of the conductor is to bring them into coherence, to listen to when something is in disharmony, and then to change the parameters of these individual instruments until everything becomes harmonic and the orchestra becomes a single agent. Everybody is on the same page, and we are playing the same music in complementary parts. And this seems to be one of the roles of consciousness, this conductor of the mental orchestra. So we can characterize consciousness from the perspective of phenomenology. What does it feel like? From the physical substrates, what are the things that we can observe when we look through a microscope? But we can also look at from the perspective of the causal pattern, right? Consciousness is a self-sustaining causal pattern. And if you look into other cultures, we call these patterns software, it's the modern name, right? And other cultures, how do they address consciousness? Well, other cultures typically are animist. And animism is this idea that living nature is governed by spirits, which means there are these non-physical agents that are intrinsically agentic and capable of experience. And they're wafted through nature and possess regions of the physical universe and form them into particular shapes, animate them. And the scientific worldview is rejecting this notion of spirits. Of course, we see this usually as a superstition. But it's a novel phenomenon if you look into Goethe's work or into Brentano or Hegel. They all believed in spirits somehow or used them in a particular way. And it's mostly in the 20th century that this notion of spirits was declared unscientific and we lost it or didn't talk about it anymore, except maybe sometimes in computer science. Here's Harold Abelson in the famous book Structure and Interpretation of Computer Programs. In this book, he describes that computational processes are abstract beings that inhabit computers. We conjure the spirits of the computer with our spells. A computational process is indeed much like a sorcerer's idea of a spirit. It cannot be seen or touched. It's not composed of matter at all. However, it is very real. And of course, he says this tongue-in-cheek, right? This is a very witty observation that he makes. It's also very insightful. And what I suggest is that there is actually something going on, because what is a computer program? It is a causal pattern. Of course, in the computer, it's stabilized because of the deterministic substrate. But there is software in nature, right? There are systems that are causal patterns in nature and that are somewhat invariant to the particular mechanisms that implement them and actually cause the mechanisms to implement them. And so from this perspective, that spirits are actually computer programs, a position that I call cyber animism, there is the difference between living and dead systems comes down to self-organizing, self-perpetuating, adaptive, error-correcting software running on the living systems. Right? There is a software running on your cell, and the software is so powerful that it can control the movement of individual molecules. And yet, when an individual molecule disappears, it gets lost, right, the software is going to try to find another molecule that plays the same role. In the same way, if one of your neurons dies, your mind is going to try to entrain another neuron to the same task and recruit it for its purposes. And up to a certain point, it doesn't care about the individual constituents as long as these constituents can all do their job in implementing the self-organizing agentic software. And so, in my perspective, software actually explains the mind-body problem. Is consciousness a biological learning algorithm? What we can observe is that consciousness does not seem to be something that only the smartest animals, like human beings like Stephen Wolfram, can attain. It's something that babies can do. And if babies don't wake up, they don't learn. They don't learn to track a finger. They don't form a self-model. They don't form a relationship between self and environment. They remain vegetative. So for our type of mind, consciousness seems to be absolutely crucial, and it seems to be discovered at the beginning. And this suggests to me that consciousness is possibly not simply an aspect of the complicated organization of our mind, but the thing that creates this complicated organization in the first place. Right? It's a colonizing pattern that is creating coherence in the mind, starting from this notion that there is an observer that observes itself and stabilizes itself in this way. And I call this idea that consciousness is the thing that creates the world in our minds, the Genesis theory. AI can be understood as a philosophical project. It's basically in the tradition of Aristotle and Leibniz and Frege and Helmholtz and Tarski and Ludwig Wittgenstein, that we can understand the mind by mathematizing it, by creating a mathematical model of mental activity. And in a way, mathematicians are also doing this, I think, because mathematics is a general theory of representation, of how thought can work, not just for the human mind, but for any kind of mind, even non-physical minds. And AI itself is not a model of the human mind, but it's a generalization. It's the development of tools with mind-like functionality. And what AI can do for us, it can work to integrate this Tower of Babel that we have in the cognitive sciences and in science and culture in general. We have disparate disciplines that have different methodological limitations. Philosophy of mind is mostly done in natural language, so it's very hard to say something true in natural language because natural language is ambiguous and contingent on the context in which we use it and acquire it. It's usually not completely defined into first principles. If you look at mathematics, mathematics is built from the ground up, so we can know how truth is defined in our language, but it's very difficult to say something in this ground up language about the real world, about the world of our experience, about the complexity of the world in which we are in. So we use mathematics to build simplified toy universes and hope that they're similar enough to the world that we want to describe. And so it's very hard to do philosophy using the tools of mathematics. Psychology has given up on the notion of the psyche sometime in the 20th century in an attempt to become positivist and to submit to the institutions of peer review in the best possible way, where it's much harder to develop far-reaching ideas in a way in which Piaget and Freud and many others did. Neuroscience is mostly concerned with the shenanigans of a single cell type and not so much about what these cells are doing together. Linguistics has failed basically to generalize in the same way as the AI models did. But all of these sciences provide insights, they provide perspectives that we need to let play with each other. And I think the way to do this, the right methodology, is to make models that we can actually test by running them, by simulating them as computer programs. And this generality of computational modeling means that every sequence of observables can be modeled as representational patterns, and we can model the evolution of these things, these discernible differences of information, by modeling the transitions and the regularities and the transitions between them. And that's this idea that I share very much with Stephen Wolfram. So the foundation of this AI philosophy is what could be called computationalist functionalism. And functionalism is this idea, it's an insight about epistemology. It says that the objects that we are looking at, we cannot construct them over their essences, about what they truly are like, because we don't have access to what things are truly are like. And the things that we call things are actually constructs that human minds have discovered by making sense of the patterns that our minds are interacting with. And the objects that we are constructing in our minds are defined over the changes in observables. An object is defined in how its presence changes the evolution of the world. It's defined by its behavior. And that's what we mean by functionalism, that an object is basically a set of functions that describe how reality is changing when that object is present. And computationalism is constructivism. It's basically the insight that in order to make a mental model of something, to perceive something, to interact with something, you need to build a representational language. And the representational languages that we can use for this, they have to be constructed step by step. This means they are constructive language, computational languages. And so computationalist functionalism is an epistemological position. It's a position about the nature of knowledge, that its contents in a representational language, and of the origins of knowledge, that we construct the contents of this representational language by observing behavior of observables. And computationalist functionalism is not the claim the computers can think. Right? It's much more narrow than this. It's much more basic than this, much more foundational, much more boring than this. It's an idea that is also shared by physics and by many other fields. And so it doesn't imply that consciousness can work on every substrate. It could be that consciousness requires mechanisms inside of individual cells that are so complicated that we cannot simulate them using GPUs. It does not imply that there is nothing below the particle level, right? It does not say all these things. It does not imply that hardware is enough to compute consciousness. This is an empirical question that we have to resolve, and this is an open question that we want to answer. And so our current hypothesis that we are starting out from is that consciousness can be understood in the context of mental states, and these are representations inside of a mind. And these representations can be explained as patterns of messages between cells. And then we have this genesis hypothesis that consciousness is probably the thing that forms very early on in mental development. And its role is to create coherence, like a conductor does in an orchestra. But if you have a more specific notion, of course, it's the minimization of constraint violations, of weighted valence constraint violations. So our representations become coherent. It's something like a consensus algorithm. And from Gary Edelman, we take this idea of neural Darwinism, that consciousness is discovered in every mind individually through some process of evolutionary search. It's basically a pattern that your mind discovers some form of organization similar to the secret of government. Right? Government is something that many societies have discovered, many civilizations have discovered independently of each other. And government is a pattern. It's a causal pattern. It's not just a bunch of people. And this causal pattern is a very specific one. It's not simply the ability to bully people, and you just get a gang. Right? To have a government, you need to make the bullying recursive. Once you get people to bully other people on your behalf, and this scales, right? Then you have a self-organizing thing that is going to spread until it hits a geographic boundary or another government. And so government and social systems is producing a state-like organization that forms a collective intelligence. And it's tempting to think that a similar colonizing pattern is emerging in our own brain when the strange loop sparks itself into existence, when it ignites and the observer forms and imposes a shared language, a shared reward architecture, order, and coherence onto the mind. And these things, of course, are virtual. They're patterns. And this way in which I exist in my mind, the world exists in my mind, is not how the world exists in physics. This is virtual. I exist as if. The way in which I experience me to be is what it would be like if something like me would exist instead of just a bunch of cells. Right? There are a few trillion cells that shamble through the world, and they behave as if they were one entity. And so we create a virtual entity, a model of what this would be like, and a model of what would this thing perceive and what would it care about. And I find myself to be that thing. And consciousness seems to be instrumental in creating this type of self. In the space of theories in which we are, there are many convergent theories, for instance, Sparse and Dehaene's global workspace theory, Graciano's attention schema, Christoph's theory that consciousness can be understood via coherence and patterns of coherent interaction between neurons, Grossberg's adaptive resonance theory, and Dennett's notion of the Cartesian theater, the idea of higher order thought that was formulated by Rosenthal and Caruthers, and Bengio's consciousness prior, Carl Friston's predictive inference frameworks, and Metzinger's insight about the reflexive phenomenology of self-modeling. There's a large space of theories that are complementary and that are part of this answer that we're trying to find by testing computational theories of the mind. And so the questions that we have is, can we search for consciousness by setting up the search space in a similar way as the search space might be set up in the mind of a young mammal? What is the relationship of consciousness to self-organizing learning? Is this really best understood as a learning algorithm for self-organizing systems? And is the reason why we are all conscious because there is no simpler one? Right? Otherwise, nature would have maybe forced some human beings which are not conscious yet still are able to learn, and we don't observe that, which suggests this maybe is actually the simple solution. Then the universality theory says that when we train models on the same data, on the same domain, then the architecture doesn't matter very much. What matters is really the structure of the problem with respect to the feature hierarchy that we're going to derive from it. And this would mean, if this is true, we observe this in computer vision models, it doesn't really matter which vision architecture you're using initially for your neural network when you start training. After you train, the thing has learned very similar features in all the different models. And these are roughly the same features that we discover in the human brain, despite biological neurons being extremely different from neural networks. And so if we take this idea seriously, and it's an untested hypothesis with respect to higher level things, is if you train a model on input and output of human beings, to which degree is it going to form phenomenology? And what is a minimal system that discovers itself? Would it be possible, like Carl Friston suggests, to build a system that is not trained on text, but is trained on moving a body in a world, and then teach it language the old-fashioned way, and then talk to it, and at some point it spontaneously describes self-report? Can we build systems that, what Mike Levin pointed to, that have perceptual empathy and resonance across each other in the same way as we observe this between organisms? Can we basically crack the code in which minds work? Can we build things that can extend human minds in this way? And of course, more deeply, there is this question, what role will machine consciousness play in the world? How can we deal ethically with machine consciousness and artificial phenomenology and the possibility of non-human agency? And how can humanity coexist with non-human intelligence?